Today I am going to start a new chapter of chemistry, that is language of chemistry. This is very important topics, a very important chapter for those students who are having lot of problem in the chemistry. As you know that a substance can behave as a matter if it satisfies three conditions. First, it occupies space. Second, it has mass or weight. Here don't get confused. Mass means quantity of matter. And when we take quantity of matter with acceleration due to gravity, then it becomes weight. And third part that is very important, we perceive with our sense organ. We perceive it with our sense organ. So these three conditions are very important for any substance to behave as a matter. And matter has the following components: atom, molecule, compound, and mixture. Language of chemistry is very important because it fulfills the demand of formulas, equation, chemicals. Apart from that, a very important chapter we will study in standard 10th standard ICSE, that is mole concept, or the same topic you will study in standard 11, that is chemical combination. Chemical combination. So if you have problem in this part, in this chapter, you cannot solve numerical based on mole concept and chemical combination. That's why a number of students in my life, I have seen a number of students have problem with this part, and they say that chemistry is very difficult for me because they don't have confidence, they don't have concept of this. So if you want to become this chapter, if you want to become your chemistry strong, you have to make this chapter very well. So the first part that we are going to discuss, atom. According to Dalton's theory, atom is the smallest part of the matter. You know that? According to Dalton's concept, it is the smallest part of the matter, but we know that atom is divisible into three fundamental particles. You know it very well. It is divisible into three fundamental particles: electron, proton, and neutron. We will study this topic later on, but first let me explain what is differences among atom, molecule, compounds and mixture. Because once you have idea, suppose if I say find molecular mass of H2SO4. Here what is H2SO4? Is it atom? is very, very important. How we are going to represent an atom? It is represented in the form of symbols. For example, we take nitrogen. Its symbol is N. Carbon, we write its symbol is C. So normally, the first letter of the name of an element, the first letter of a given element is used as its symbol. But some elements, for example, you can take example of carbon and copper. Here, carbon and copper both have CC letter common. So here we take two letters to make distinguish between carbon and copper. Here carbon, for carbon we take first letter, and for copper we use Cu. Actually, copper Cu is taken from its Latin name cuprum. Cuprum. So atoms can be shown by its symbolic form, and that symbol is very, very important to make molecule, to make compound, to make mixture. So once we have idea of this, this will become very, very easy for us. Second thing, if we are going to discuss molecule, then a molecule is combination of two or more than two similar atoms. It is combination of two or more than two similar elements. You can say elements or atoms also you can use. For example, if I say H2, what is H2? You can say one molecule of hydrogen. If I say O3, what is this? One molecule of ozone. If I say P4, one molecule of phosphorus. So molecules can be diatomic, it can be triatomic, it can be tetraatomic. So for tri or tetra, we use another words, that is octa, we use polyatomic. We use the word polyatomic. Very, very important part, that molecules we use two or more than two similar elements. This is very, very important point. Here we use similar elements. Compound is combination of two different elements. For example, I am going to use H2. H2. It is a compound. Because here we are going to use two different atoms, two different elements, and they have a fixed ratio. Anything which has two or more than two different atoms and they are present in a fixed ratio, it behaves as a compound. So you can distinguish that in molecule we are going to use similar elements, and in compound we are going to use different elements having a fixed ratio. And when we are going to take mass of an atom, mind it, when we are going to take mass of an atom, it becomes atomic mass. And when we are going to take mass of a molecule as well as compound, it is called molecular mass. Molecular mass. So don't get confused. Molecular mass means either you take mass of molecule or mass of compound, which is sum of atomic mass of the elements. For example, you are going to find molecular mass of H2SO4. H2SO4. So here you have to take sum of atoms exist like this. Molecules, combination of two or more than two similar atoms. Compound is combination of two or more than two different atoms having a fixed ratio. Mixture is combination of anything in any ratio. Combination of substances in any ratio. It is not fixed. For example, we can use sand. It is a mixture. So these are the some basic concept that is going to distinguish atom, molecule, compound and mixture. After that, we need to discuss the structure of an atom. One thing you should not forget that in language of chemistry, first we have to discuss about atom and its structure. Then we have to study atomic number. Then we have to study electronic configuration. Then we have to study valence electron. Very important topic. Once you have idea of these part, very easily you can make formula, you can make equation, you can memorize the topic and you can understand the higher parts of your subject, chemistry. And then last is valence. So once we have idea of atom, we can get idea of all these things, that is atomic number, that is electronic configuration, that is valence electron, valency, and once we have command of valency, then we can easily make formula, that is chemical formula. This is very important part, formula, how to make formula. So now I am going to discuss atom and its structure. As you know that atom has three fundamental particles. Atom has two parts. First is its central part, that is called nucleus. And inside the nucleus, protons and neutrons are present and they are collectively known as nucleons. Just outside the nucleus, there are imaginary circular part, imaginary circular orbit, which is called shell or orbit. This is K shell, L shell, M shell, and this is called shell, or you can also say it is orbit. N is equal to 1, N is equal to 2, N is equal to 3, N is equal to 4. We can compare a structure of atom as the solar system. The way sun is in the center and the planets are outside the sun, similarly electrons are arranged around the nucleons. So this is the structure of an atom. You can say that an atom has two parts. First is its nucleus and second is the extranuclear part. Extranuclear part. In the nucleus, we get two fundamental particles, proton plus neutron. And outside the nucleus, we have electron. Don't forget that proton is a positively charged particle, neutron is a chargeless, and electrons are negatively charged particles. This is very important. And an atom is neutral because it has equal number of positive and negative charge. That's why an atom has no charge. Suppose if I say Na has no charge. We will discuss this topic after getting the idea of atomic number, that why an atom sodium has no charge. When sodium will turn to Na+, how Na+ combine with Cl- to form NaCl? 1 by 4. Now what is atomic number? This is very important part. Atomic number, often students get confused by atomic number and mass number. Atomic number, it is represented by symbol Z, and this is equal to number of proton present in the nucleus. For example, if I take atomic number of nitrogen is 7, it means nitrogen has 7 proton. And number of proton is equal to number of electron for an atom. You can say that nitrogen has 7 proton as well as 7 electron. That's why it is neutral. An atom has equal number of proton and electron. That's why it is neutral. Now, how we are going to arrange these electrons in the given subcell, in the given cell and in the given orbit, each called electronic configuration. Arrangement of electrons in the given orbit or shell, that is electronic configuration. It is arrangement of electron in the orbit or shell. So, just I am taking 1-2 examples to explain all these things. How we are going to find the electronic configuration of different elements, how we will find valence electron, how we will find valency. This is very important concept. Once you have an idea of this topic, very easily you can make formula, you can make equation, and the further whatever things required to understand chemistry, it will be easy to understand and explain. Atomic number, it is represented by symbol Z. Electronic configuration, arrangement of electron. In the shell. For example, if you take example of nitrogen, then in the first orbit we can put 2 electrons. There is a formula that maximum electron can be put in the first orbit is 2n square. Maximum electrons can be taken in the first orbit is 2n square. If you have first orbit, then you can put 2 electrons. So, for nitrogen we can put 2 electrons in the first orbit and it has 5 in the second. This electron is called valence electron. That is electron present in the outermost orbit. Electron present in the outermost orbit or shell is called valence electron. Once we have idea of valence electron, then we can easily discuss about valency. We can discuss formula. What is valency? What is valency? So you can say that number of electron that an element lose, gain or share. The number of electrons that element can lose, gain or share is called valence. Mind it? If you take electronic configuration of sodium, then you can find that atomic number is 17, so you can write 287. If chlorine will take one electron from other element, then its stability can be fulfilled. So its valency is minus. One thing remember, those who are positive charge bearer are called metal, and those which are negative charge bearer are called non-metals. In methane, CH4, carbon can share 4 electrons with hydrogen. This is the daughter structure of hydrogen. This is the daughter structure of hydrogen. So here valency of carbon is 4. So don't forget, it is the electron that elements can gain, lose or share to fulfill octet or duplet configuration. Duplet basically what we use for light elements. There are some elements like hydrogen, helium, lithium, beryllium, boron. For these elements we need duplets. For stability they need 2 electrons in their outermost orbit. And except these 5 elements, the other elements will fulfill their octet configuration. So that's all for today's class. In the next video, we will discuss how to make a table, organized table related with atomic number, electronic configuration, valence electron, valency, and how we are going to use valency to make formula. Thank you.